All right, so our plan today is we're gonna do the first question only on the front. Let me see if I don't have any extra of that anymore, because again, our copy situation is kind of bad. If you just write it out on a separate sheet, you'll be fine. Can you just write this one on a separate sheet? Oh, you found them? Okay, no problem. So on your worksheets, we're gonna do just question one only because the two on the back are repeats. If you wanna re-practice them, you're more than welcome to, and then we're gonna change gears and do some quiz review. All right, so the document that you need in front of you, or again, you can do these in your notebook, it makes no difference to me, is we are going to do this problem. All right, so we are going to go through Descartes one more time, just again, as a tool to restrict the possibility. Okay, number one, here's what you're given, and we're going all the way with this. So the first thing we're going to do is practice one more with Descartes' rule of signs to narrow down our possibilities. So with Descartes, we're going to look at our sign variations of the original and when we replace x with negative x. So how many sign variations do we see here? 1, 2, excellent, 3. So we have 3 sign variations. So what that indicates, the 3 sign variations, is that we can have 3 positive real roots. Okay, so I'm going to come over here, make a little chart for you. So I'm going to say the positive, I'll keep it short and simple, the negative possibilities, and then your third column, just like you did on homework, where your irrational and your imaginary. I'm going to say irrational / imaginary, and those are always the ones that come in pairs. So right now we know 3 of these. Now, what is the degree of this polynomial? 3. So isn't that all of them? So this I'm going to write, excuse me, 0, and this I'm going to write 0. Now what I do is I immediately take these 3 and I subtract 2 from this, which means I could also have 1 positive real. Okay. And right now, that is all you know. So I'm going to stop and I'm going to plug in my negative x now. So now I'm going to replace every x with a negative x. So we would go negative x cubed minus negative x squared plus negative x and minus 1. And this is going to help me determine how many negative real roots I would have. So this is going to stay negative. And then my negative x squared would go positive and then gets negated in the front. And then minus x and then minus 1. Okay, how many sign variations? 0. So we have 0 sign variations. So how does that help us? It tells you that you have no negative real roots. So I have 0 negative real roots. So this has to be a 0, which means this column has to be a 2. Perfect. Now, next part. So I'll call this just like up here, part B. Now you're going to use the rational root theorem to list all your possible roots. And this one should be fairly quick. All right, so part B. This is your rational root theorem. This is your P and your Q. The rational root theorem to list all your possibilities and then find them. So we're going to do P over Q. So factors of P over factors of Q plus and minus. So you're going to look up at the top, and what was our P? It was 1. Oh, that's nice, right? What was our Q? 1. Okay. So the only possibilities we have are going to be 1 and -1. But guess what? What did Descartes help you rule out? Negative. So don't you already know which one works? Yes. So, and then we determined with Descartes that we don't have the negative. So you don't even have to use your calculator for this one. You can go right to the synthetic and start dividing the 1. So we know that this is going to work. So now I'll call this part C. And I want you to find all the actual roots. So find all of them. If it just says list the possibilities, you're done right there, but now we want to find them all. So you are going to take the +1 and synthetically divide it through the original. Your original was, so we have a 1, a -1, a 1, and a -1, no placeholders required. So the 1 comes straight down. 1 times 1 is 1, and I get nothing. Multiplying, you get 0, add straight down, you get 1. And again, we already know that this should work, and that confirms that. The remainder of 0. So what you are left with is a quadratic because you started with a cubic. So I am now left with just x squared plus 1, and now I have to solve this. Typically, we do quadratic formula, which you're more than welcome to do, but there's a faster way to do this one. So this one, I'm going to go instead, x squared plus 1 equals 0. And we're going to go x squared is equal to -1. And how many roots do you need to generate from this equation? 2 of them. Keep that in mind as a way to help yourself remember that plus and minus. So plus and minus, square root, and then plus and minus, square root, and this is where your other 2 roots come from. So x is equal to plus and minus what? I. Very good. So now let's just summarize all of our answers. So in this particular question, we found that we had 1 real rational root at 1. So 1 real rational root and 2 imaginary roots. And 2 imaginary. And our answers were +1 and then plus and minus I. So again, you have 3. Okay. How do you feel with that question all the way through? Pretty good? Okay. So in your notebook, change gears a little bit, and we're going to do some quiz review if you'd like it. Quiz review, okay? Otherwise, I mean, if you want, we can start new stuff. Okay. I picture people say no to that. I don't really want to either. Because, you know, you're going to forget things. Rather just start fresh after. So in your notebook, find a place, and you can call this Quiz B review. So this goes all the way back to your factor theorem, remainder theorem, and your rational root theorem too. Quiz B review. All right. Get yourselves organized and start copying when you're ready. You can abbreviate anything you'd like. Okay, then I'm going to put parentheses around this just to kind of distinguish it in your notebook. So 14x squared plus 61x plus 84 divided by x minus 4. And this first one is going to say use the remainder theorem. So use the remainder theorem. Abbreviate. To find the remainder. So to find the remainder. I'll just say R. So this is a division problem. The remainder theorem is division. What type of division works best with this scenario? Synthetic. Yep. So when you see remainder theorem, I want you to do synthetic division. So what do we need to do with the factor x minus 4? Switch the sign. Yep. Anytime you have a factor is when you switch the sign. Sometimes that does get confused. Okay, do we need any placeholders? No. So we're gonna go 1 and then 14 and then 61 and then 84. All right, first number comes straight down. Multiply, add, multiply, that is 72. Add straight down, 133. I'm gonna need a calculator. So then you're going to do 133 times 4, which is 532. Is this going to work? Definitely not. So this gives us a remainder of, anyone have it yet? 616. Good. And that is your remainder. So there's your first part. It actually just asks you for the remainder, so you do not need to put it back together. Now in question B, I would like you to answer. Is x minus 4 a factor? And what's our answer to that? No. In your reasoning? Has a remainder. Yep. So you're going to say no, and you have to give me a reason. You're going to say has a remainder. Does everyone feel confident with that one? Mm-hmm. You can just leave it like that. Actually. Yep, because it's a good question. It just asks you for the remainder. But I would take it. Yep. If you want to write the whole thing out, you can. So number 2 is going to be a factor theorem question. You can fit that down here, I suppose. So now I would like you to use the factor theorem. Factor theorem is when we did the substitution. We use the factor theorem to determine if x plus 5 is a factor of, and let's go f of x equal to x cubed plus 10x squared plus 19x minus 30. So you're going to require a calculator for this. And if I gave you that x plus 5 is the factor, what do we substitute in? -5. Good. So again, your factor theorem is going to be a substitution. So I'm going to go f of -5 equal to -5 cubed plus 10 times -5 squared plus 19 times -5 and minus 30. Does anyone have that solution yet? It's 0. Okay, thank you. F of -5 is equal to 0. And I did give you a part B on this. Oh, it's already in there. So is this a factor? Yes. So in this instance, we're going to say yes, is a factor And then you can say since, I don't know, f of -5 equals 0. Something to that effect. Do you need a synthetic division problem, or do we have that under control? Do you want a synthetic division problem? Yes, okay. I saw some head nods. That's fine. That's okay. I am happy to do it if you want it. So it's going to just say use synthetic. Keep it simple. And I want us to do 3x to the 4th and minus 2x squared plus 7 divided by x plus 2. So what needs to take place with that x plus 2? What do I do with the sign? Flip it. Yep. In addition, the synthetic division requires what this time? Placeholder. The placeholder. So you've got 2 of them. So I'm going to go 3. I'm going to go 0 for my cubic, -2 for my degree 2. Degree 1 is missing, and the constant is there. So double placeholders. 3 comes right down. Multiply, add, multiply, add, multiply, add, and then 40, and then remainder of 47. You may not leave your answer like this, because it doesn't just ask you for the remainder. So this one, I do expect you to write it out. You took a quartic function and divided it once, which results in a cubic. So my answer is 3x cubed minus 6x squared plus 10x minus 20 plus 47 over my divisor, x plus 2. I like to do this just to distinguish that remainder. And keep it nice and clean. All right, so number 4. I want us to just simply determine all the possible rational roots. Do not need to find them. I'm going to just say determine all the possible rational roots. So again, you do not have to do Descartes unless you really want to. I would accept your answer if you eliminated some of the answers you could rule out. So determine all your possible rational roots. And your function is f of x equal to 2x cubed minus 5x squared, that's a 5, sorry, plus 7x minus 7. So this is going to be your p over your q. Remember that the constant represents p. The coefficient of the leading term represents q. So p over q, plus and minus. Okay. What are the factors of 7? 1 and 7. Nice and easy. Good. And then the factors of 2 are 1 and 2. So my possible rational roots, you're going to pair them all together. So 1 over 1 is just 1. And then 1 over 2. And then 7 over 1. And then 7 over 2. And again, that is sufficient for your quiz. I don't need you to rule anything out with Descartes unless you would like to. Because again, we are not taking your calculator away from you. How do we feel with determining all possible rational roots? Pretty easy. Okay, and then let's do one all the way through. This will be your last one. So last will be number 5. So I would like you to say, given f of x first, This is going to be equal to x cubed minus 8x squared plus 17x minus 30. I want a list of all possible rational roots and then find them all. So all possible rational roots. And then we're going to find them all. All right, so we're going to do P over Q. So factors of P over factors of Q plus and minus. This list is bigger. All right, what are the factors of 30? Okay, Sarah, one more time. 1, 2, 3, 5, 6, 10, 15, and 30. Yep, you got them all. Factors of 1 are just plus and minus 1. So here's your list to check. And I want to show you your table and how you can turn this into ask mode instead in the instance that you have a fraction ever. This is 1, 2, 3, 5, 6, 10, 15, and 30. And this is a degree 3 polynomial, meaning when we're done, we need 3 roots. Okay, so here's a trick in the calculator that you can do. And again, this is very helpful when you have fractions to check, is we're going to do our table and change it to ask mode. Go to second window. No, I'm sorry. There we go. Yeah, hit second window. And what you need to do is change your independent variable to ask. So change independent variable to what mine says ask. And now go to your table. And now you're going to simply start typing them in once your function is in the y equals. So go to your y equals, type in the original. I'll leave that there for a second so you can see it. And then basically we're just going to start trying that list. This is a very helpful tool if you ever have possible rational roots at like 1/2 and 2/3 that look very hard to distinguish on a graph. So this is how you could tell for sure. So I'm going to go to my table and try some. So the first possible rational root was 1. Doesn't work. How about -1? Does that work? Nope. How about 2? Nope. How about 3? 4 didn't work. 5, 6. Did we find it? There you go. So again, if you don't want to look at it graphically, this is a great option as well. So 6 works. So I'm going to go back and synthetically divide the 6 because we verified it is a root. All right, we have 6. Check that one works. So B is going to be to find your roots. So I quickly go 6. And why did I not flip the sign? Yep, not a factor. Excellent. So I go 1, -8, 17, and -30, and you know that this is supposed to work. So 1, 6, -2, -12, 5, 30, remainder of 0. So we're good. So what results is x squared minus 2x plus 5, which this time you're not able to just quickly solve. This has to be quadratic formula. So I go x is equal to 2 plus or minus the square root of -2 squared minus 4 times 1 times 5 all over 2. All right, what do we get here for our discriminant? So 2 plus or minus? I have 4 minus 20, which is equal to negative 16. Good is my discriminant over 2. I am left with x equal to 2 plus or minus 4i over 2. And then you must divide everything by 2. All right, so we are all set. We're just going to summarize these answers. So this was a degree 3 polynomial, meaning we needed 3 roots, and we have them. We have 1 real root, 2 imaginary. So we had 1 real rational root, and we had 2 imaginary. So 2 imaginary roots, and our solutions were 6, and then 1 plus and minus 2i, which you may certainly leave just like that. Okay. How does everyone feel regarding their quiz tomorrow? Pretty good? Just like those. So nothing further than that. And again, if you want to use Descartes, you can. I'm not going to require it. Just because you've got access to your calculator. Yep, question?
So how do you know when you
As opposed to solve by square root method. Do you notice how this has all your terms A, B, and C? The other one that we did only had an A and a C. Yep, and yes. And also too, I mean, you always still check them to see if they're factorable, but pretty much any instance that you're going to see with rational root theorem should be quadratic formula. I mean, when in doubt, you could always do quadratic formula with the other one too. Yep, good question. Any other questions? Okay, your only homework is to just study, okay? And then we will do new content when you return from break.